All right, so today we're going to solve logarithmic equations. So this little first part right here says, what happens when you try to calculate the log of -5? Does anybody remember what happened when we did logs of negative numbers? Yeah, there was a domain error, right? So just keep that in mind, that sometimes we still have restrictions on our domain. When we have restrictions on our domain, that usually means that we can have extraneous solutions. So we want to check our solutions to make sure that they really work when we get them. Does that make sense to everybody? Okay, so here we go. We're going to learn some different strategies on how to solve logarithmic equations. So the first strategy says, if you have logarithms in the same base, you see how this is log base b and this is log base b, you can forget that the logarithms are there and just solve the algebra part by setting them equal to each other. Okay, so looking at this first example right here, I have log base 4 of x plus 3, and I have log base 4 of 8x plus 17. See how they have the same base? So guess what I get to do? Forget about the logarithm being there, and I get to just solve the algebra. So I get to do x plus 3 equals 8x plus 17. All right, so far you're liking logarithms, right? That's pretty easy. Same base, just forget that they're there, solve the algebra. So what am I going to do to solve this equation? Subtract the x. When I do that, I get 3 equals 7x plus 17. Then what? Yeah, subtract the 17, and I get a negative 14 equals 7x. Divide by 7, and x equals negative 2. So just a second ago we said if we took the log of a negative number, we got a domain error and we needed to worry about that. Just because x is negative 2, does that mean that it's not going to work? No, because it would mean that I'd have to take the log of a negative number. And if I put negative 2 in right here, I still get a positive number. If I put negative 2 in right here, I still get a positive number, right?
No. Negative.
Yeah.
Negative number.
Negative 2 times 8 is negative 16, plus 17 is still positive 1.
You're right.
Okay, we're right, we've decided. So when we take the log of positive numbers, we're going to get a solution. So that's probably as far as I need to check. Does that make sense to everybody what we're checking for today when we're checking our solutions? Okay. All right, number 2 right here. Are they the same base of logarithm?
Yeah.
Yeah, they're both base 2. When they're both base 2, we can just kind of pretend like they're not there. Rewrite the algebra part, so 2x minus 1 equals x plus 5, and solve the algebra. So what do you want me to do? Subtract the x. In the same step, are you guys okay if I add the 1? Right, I'm going to have to do it, so can I just do it now?
Yeah.
Add the 1 over to the other side. So here it cancels to just x. Over here it cancels to just 6. So then again, just go check up here real fast to make sure you're going to have positive numbers here. So that will be positive, this will be positive, so we're good with x equals 6. Questions on how to do that particular kind of problem? That's pretty easy, right? All right, here's the second strategy. The second thing that we need to do is when we see a logarithm that looks like this and we're like, I don't know how I'm supposed to solve that, we're going to rewrite it in logarithmic form instead of in exponential form. Do you guys remember how we rewrite into logarithmic form? We do the circle. We circle it around. So this is going to be log base 4 of the number 15 equals x. Is everybody okay with me rewriting that? All right, now does anybody remember a rule from yesterday that would make this a calculator problem for me? It's called the change of base formula. It said if I had something that looked like this, I could take the log of the big number divided by the log of the little number, right? And it would be able to be done on my calculator. So from here, I'm just going to do the log of 15 over the log of 4. We're going to punch that in our calculator, and that's going to give us our value for x. So when you punch that in your calculator, use your fraction key, right? You guys remember me showing you how to do that? Anybody got that for me yet? Round it to 2 decimal points for me, would you? X equals what?
1.3, there is 1.4. I was trying to, the first three or first? 1.95.
I got 1.95 also. So check when you punched it in and see.
The log of 15 divided by the log of 4 is 1.396.
You make sure his mode's in degrees. Okay, 1.95. You guys agree with me on that?
No.
Everybody but Brandon agrees with me on that? Okay. I'm going to move on to this next problem. In order to write this one in logarithmic form, I need to get the exponential part by itself. So I'm going to get rid of that 3 first to the other side. I'm going to subtract the 3 over. So I have 5 to the x plus 2 power equals 22. Now I can circle it around and rewrite it. So you guys shout out for me, what's it going to be?
Log base 5
Of
of 22.
good equals
Excellent.
perfect. Okay, now what am I going to do with this side? I'm going to do the change of base formula. So the change of base formula says I can take the log of the big number over the log of the base, which is the small number. It would still be equal to x plus 2 in this case because of the other side. So you're going to punch this into your calculator and get me a number for that.
1.92.
Somebody agree with that? 1.92. Okay, so 1.92 equals x plus 2. What's my last step? Yep, subtract 2 over. So I get x equals
Negative 0.0794.
0.079.
Oh, wait, I lied. Negative 2.079.
Anybody verify that?
I subtract what I got by 2.
I got negative 0.08.
What?
Yeah. Somebody's having a bad calculator day. It might be the calculator though.
Having a bad brain.
Yeah, the calculator's having a bad day. Okay. So you guys, is this going to be an okay answer? If you put it up here, you're going to have a positive power. So it's going to probably work just fine anyways. But if we had a negative power, that would work fine in most cases also. But my answer is negative 0.08. Okay. All right, next kind of problem. This one is in exponential form already with the e to the x. So here's another kind of rule that we can use. We can, well, there's a couple of things we could do. The first thing I want to do, though, is isolate that e to the power. So how do I get rid of the 40? Divide by 40. When I do that, I get e to the 0.6x equals 6. You guys agree with me on that? All right. Can you circle that around for me? Does anybody remember what base e is in? It's the ln. So I'm going to have the ln of 6. Okay, I don't have to show the e anymore because I do the base of it. So the ln of 6 equals 0.6x. That makes pretty easy math, right? That circle around thing works almost every single time on these kinds of problems. So on your calculator, find the ln of 6, round it to 2 decimal places. I got 1.79 equals 0.6x. What's my last step?
Divide by 6.
Yeah, divide by that 0.6.
No, that's
And I got 2.98. Do you guys agree with me? All right, let's try another one then. Is it ready to circle around the way that it is? No, what do I got to get rid of? The 1. So subtract the 1 over. You get e to the negative x equals 9. Now is it circle around ready? It is. What's the base on the e? ln. So I have the ln of 9 equals negative x. I'm going to take the ln of 9. 2 decimal places would make that 2.2, huh? Because the 2.197 would round to the next, which would be 2.2. Everybody's okay with my rounding? That would be equal to negative x. How do I get the negative off the x? Divide by negative 1. So my answer is a negative 2.2. Now go check it real fast. When you put it up here, you'd have e to the negative 2.2. So is that going to be okay? Because a negative makes a positive, so we're good. Okay? All right. This time we're going to go the opposite direction. We're still circling around here though. Okay? So just do what I've taught you the last few days. You're going to be fine. Rewrite this for me. What's it going to be? 4 to the second power equals x plus 3. So this was already in logarithmic form, so we were going back to exponential form, right? When it's in log form, we go back to exponential. The ones we just did were in exponential form, so we went back to logarithmic form. Okay, this is easy to solve now, isn't it? What's 4 squared? 16. And what do I do to get the x by itself? Minus the 3. So what's my x value? 13. Okay. All right, you guys got it this time. Circle it around for me. Tell me what it is. 5. Yep. Perfect. Nice job. Okay. I put parentheses there. They're not necessary. Not sure why I put them. I was just copying it from up there. But I really get 5 squared, which is 25, equals x minus 4. That's really simple to solve. What do I do now? I add that 4 over, and I get the number 29 for my x value. Okay. I'm not too worried about checking it because it's not a power. And I know that 25 minus 4 is still positive, so taking the log of it's going to be positive still. Okay, over here. Same thing, but still before I can write the power, I got to have it isolated. So I can't have that 4 by the ln of x. So what do I got to do first? Divide by 4. So I get the ln of x equals 6.25. Okay, what base is the ln in? So when I circle this around, I got it figured out. The base is, 10 is for the log. What's the base on the ln? E. You're right. So it's e to the 6.25 equals x. That's just a calculator problem now, you guys. Just put it in on your calculator. So go hit your e to the x key. And for your power, put 6.25. And then just tell me your answer. Round it to 2 decimal points.
518.01.
Perfect. Okay. Questions on how I did that? So isolate, circle around. That's really what we're doing today, okay? This one right here, is it isolated? Nope. So what do we got to get rid of? That plus 4, right? So let's subtract the 4 to the other side. And I get the ln of a negative 5x equals 0. That's not going to scare us. We're good with a 0 still. So help me circle it around. What base is the ln in? E. So e to the 0 equals negative 5x. What's e to the 0? 1. How do I get the negative 5 off the x? Divide by negative 5. So I get x equals negative 1/5 for my solution. You can check it real fast just by plugging it in to make sure it's going to be positive. Will a negative times a negative make it be positive? It will, so I'm good right there. Okay. Couple more problems on the back. You guys are doing great. Staying with me. Thank you. All right, sometimes you have to condense the logarithms just like we did on the bell work before you can solve them. So do you see how there's more than one logarithm here? These are attached by addition, so I'm going to rewrite it as one logarithm, and instead of addition here, what's it going to be? Multiplication. So it's going to be written as one logarithm multiplied together equal to the other side. Once you condense, you can circle around, you guys. Like, always remember to circle around. So, rewrite this for me. Just shout it out. Good. Good. Yeah, are you guys okay if I multiply this through right now? What would that be? Yeah, x squared minus 2x, right? Because I can see that that's a quadratic and I'm going to have to factor it or quadratic formula it. So I might as well just multiply that through. Okay, 2 to the 3rd power is how much? 8. Now it's a quadratic, so I have to get it set equal to 0. So I'm going to minus that 8 to the other side. I get x squared minus 2x minus 8. Can you guys factor for that for me real fast? Positive 2, negative 4. I agree with that. So they come out as negative 2 and positive 4. Thank you for whispering me the answers, you guys. Okay, one last problem. Same thing. We got to condense it because there's more than one logarithm here. The reason we can't just forget about the logarithms the way that it is because of that plus 1 back behind that's missing the logarithm. So what we're going to do is isolate the logarithms, condense, and then solve. So are you okay if I just grab this whole thing and subtract it to the other side? So I'll have the log of x minus 7 minus the log of x plus 2 equals 1. Is that okay with everybody, just subtracting it to the other side? Now that it's written as subtraction, I can rewrite it as one logarithm. That would be division, right, if I'm condensing it. So I'll have x minus 7 over x plus 2, and it's still equal to 1. So did you see how I just condensed it using that condense rule? Now I'm going to circle it around. Anybody know what base this log is in? 10. So 10 to the 1 equals this. 10 to the 1 is 10, right? So can I just put a 1 underneath that and cross multiply? Is that okay with everybody? So what do I get this direction? 10x plus 20, good, equals that direction, x minus 7. I'm going to get my x's together, so I'm going to move the x this way by subtracting it at the same time, because you know I'm lazy. I'm going to subtract the 20 over, and I get 9x equals negative 27. divide both sides by 9, and x equals -3. Okay. Now, when you go and put -3 back in up here, you should probably check this on your calculator, right? Because if you put -3 in here, you'd have a -3 minus 7, which would be a -10. Can you take the log of a -10? No. Okay, so it gave me a domain error on this side, right? Did it get I guess the only way this would work is if it gives me a domain error on this side, right? Because if it's undefined on both sides, it's probably okay. But anyways, just check it to make sure that it works or it doesn't work. When you put -3 in over here, you'd have -3 plus 1, which is a -1. So you have a domain error on this side also. It's not going to work really for that logarithm to happen. Okay, so even though we solved to get -3, that answer doesn't actually work. It gives us that domain error. Okay, just a summary of how to do your problems over here if you forget what you're going to do. But always remember to circle around, you guys. That's the way we're going to solve these problems.